Introduction. Many social theories are created by a number of sociologists and anthropologists. These theories deal with social and cultural revolution. Many of them consider technological progress as a primary factor to drive human civilization developments. Morgan divides social evolution in 3 stages, including savagery, barbarism, and civilization. These stages can be divided using technological milestones. Fire is a great example of such technological milestone. White suggested that energy is a great measure to judge the human cultural revolution. White strongly believed that harnessing the control over energy is the primary function of culture. According to him, there are 5 main stages in the process of human development. Own muscles of humans are used as energy source. Domesticated animals serve the energy. In 3rd stage, energy is derived from plants, agricultural revolution. Natural resources such as coal, oil, gas are optimized for energy. In final stage, nuclear energy is harnessed. This theory was extrapolated by Nikolai Kardashev, former Russian astronomer. Through this, Kardashev's scale was created that is used to distribute advanced civilization of energy use in various categories. Approach of Lenski was mainly focused on information. He stated that information and knowledge of natural environment is the perfect measure for measuring development and advancement of human society. According to him, there are 4 stages in development of humans. Genes serve as a medium to pass information. Sentience is acquired as humans learn to pass information through their experience. In 3rd stage, humans discover or develop various signs and also learn to develop a logic. In 4th stage, language is developed, ultimately triggering the development of writing system. Moreover, he also distributed various societies into categories. These categories were derived using technology, communication, and economical status as a base. Hunter or gatherer, simple or agricultural, advanced or agricultural, industrial, special, including fishing societies. Here comes an end to the introduction. Upcoming is the main content divided into various chapters that will cover history of technology based on the time period and geographical locations. Chapter 1. Prehistory. This portion of technology history involves following sections or stages. Stone Age. The number of tools and permanent settlements in most of the Paleolithic Stone Age were very limited in human lifestyle. Most of the major technologies of that period were meant to serve objectives such as survival, hunting, and the most important, food preparation. Most important technological developments of Stone Age period are as following: fire, stone tools and weapons, and clothing. Stone and other tools have been used by human ancestors since a long period, even when Homo sapiens were not emerged, approximately 200,000 years from now. Old iron industry existed almost 2.3 million years ago. It was the main industry humankind ever known for developing and crafting stone tools for several purposes. However, the earliest evidence of the use of stone tools was found at Great Rift Valley in Ethiopia. It dates back into 2.5 million years. This portion of Stone Age is known as Paleolithic or Old Stone Age, when stones were primary tools of humans and agriculture was not developed. It came to an end 12,000 years ago as agriculture was discovered. In order to use a stone as a tool, it required to strike the core of the hard stone with hammerstone. This core had special flaking properties different for every stone type. Sharp edges were produced due to this flaking, making the stone a usable tool. Primary use of them was chopping and scraping. Most of these stone tools were used by humans during their hunter-gatherer lifestyle. They were involved in tasks such as butchering carcasses, breaking bones of animals or each other if required, chopping wood, cracking nuts, skinning animal bodies, performing other tools from stone, wood, bones, etc. Crude are considered the earliest stone tools ever used by mankind. It was more than a simple featured rock. These stones were simply the impure form of hand axe and other such hand tools of certain shape. Agriculture technology and rudiments were developed in the last portion of Stone Age, known as Later Stone Age. This era is also known as Neolithic period. Unfortunately, human from Stone Age left no written proof indicating their culture. All that we know about them is derived from archaeological sites, findings and written records produced post-Stone Age. Copper and Bronze Age. Neolithic Revolution developed the Stone Age into Bronze Age. Technology faced a lot of changes in this revolution as the agriculture was developed, concept of animal domestication was introduced, and adoption of permanent settlements has begun. Metal smelting was soon developed too. It was introduced with copper, followed by bronze. Bronze was made by smelting tin into copper. However, stone tools were still being used until a noticeable period of time in Bronze Age. Since crafters were lacking material and stone tools were abundant when compared to hard-to-find materials and metals such as tin. Fertile Crescent triggered this technological trend, which was constantly spread with time and further developments. However, many of these developments were not universal, and neither are they now, clearly indicating that the three-age system cannot act as a measure for technology history. This statement especially applies for human populations residing outside Eurasia. There are also some other isolated populations, including Spinifexa people and Sentinelese people, that cannot relate with such age system. These populations, including Amazonian tribes, still use Stone Age tools and technology and live without agricultural and Metal Age technology. Iron Age. The adoption of iron smelting technology is one of the major and most important components of Iron Age. In Iron Age, tools of bronze were simply replaced by another metal which allowed making stronger tools compared to bronze. Tools of iron were also whole a lot cheaper comparing to equivalent bronze tools. In most of the Eurasian culture, Iron Age is considered the most important step in the technology until the writing systems, languages, were developed. However, it wasn't a universal case. High furnace temperatures were required when manufacturing steel, making it comparatively harder to produce it on mass scale. However, it was also possible to produce steel by forging bloomer iron, ultimately reducing carbon content under control. Compared to copper and tin, iron ore were much famous since they were strong and noticeably cheaper. There were many hill forts in European countries, built in order to use as shelter in war periods, or sometimes they are used as permanent shelter as well. Sometimes these forts, built in Bronze Age, are expanded or enlarged. More farmland for growing populations was achieved by making land clearance more effective using stronger iron axes. Chapter 2. Ancient Developments. Some of the greatest technological and engineering developments and advances were produced thanks to significant growth of mankind in ancient period civilizations. Many societies around the globe were heavily influenced with these developments, ultimately stimulating them to adopt advanced lifestyle and governance. Egyptians. Egyptians gave birth to and were used to a number of simple machines. Ramp is a great example of such innovations. Ramps were heavily used by Egyptian people for aid in constructions. Indus Valley civilization was famous for city planning and sanitation technologies. It is noticeable that this civilization was located in a content-rich area, exactly knowing how the resources can be optimized at fullest. Ancient India too witnessed a golden age in forefront and seafaring technology. There were panels found at Mohenjo-Daro that depicts with a sailing craft. India is also famous for their early construction and architecture technology. It is described in famous literature Vastu Shastra. Various aspects related to construction and architecture is described broadly in it, such as materials, hydrology, sanitation, etc. Mesopotamians. Mesopotamia was home to Sumerians, Assyrians, and Babylonians. Past some time, people from these societies were said to have invented wheel. The wheel, actually. However, it is often challenged by new findings. They lived in well-organized cities since 4000 BC. Throughout these years, a well-developed and sophisticated architecture was developed by them. Mud, bricks and stones were their main construction engineering components. True arch was also a main element in their construction techniques. Walls developed by Babylonians were massive enough to be recorded as wonder of the world. Advanced water systems were developed by Mesopotamian people in terms of transport, irrigation and catchment systems. These water bodies were up to 10 kilometers long sometimes. Hilly North region is a great example of such engineering. Sophisticated drainage systems were used in their houses. Writing system was also developed in Mesopotamia. Earliest form of that system was cuneiform script. There are found many clay tables and stone inscriptions in their region. Bronze technology was adopted by these civilizations for tools, weapons and statuary art as well. By 1200, they advanced enough to be able of casting an object 5 meters long in a single piece. Gerwan aqueduct, that dates back in 688 BC, is the biggest proof of their technological advancements. It is crafted with stone arches and waterproofed with concrete. Astronomical diaries of Babylonians are around 800 years long. Their astronomers could plot the motions of planets. They were capable of predicting eclipses as well. Chinese. A significant number of first known discoveries and developments are in the accounts of Chinese. Following is a quick glance at their contribution in technological development. Seismological detectors, matches, paper, sliding calipers, piston pump with double action capabilities, cast iron plough, seed drill with multiple tubes, wheelbarrow, suspension bridge, the parachute, natural gas and fuel, compass, raised relief map, propeller, crossbow, south-pointing chariot, gunpowder, block printing, phosphorescent paint, movable type printing, chain drive, clock escapement mechanism. There is no doubt why they are one of the most advanced nations of present time and a superpower as well. Gunpowder was a significant invention as it provided base for discovery of solid fuel for rocket. China managed to achieve this goal in the year of AD 1150, almost 200 years from invention of gunpowder that was later used as solid fuel in rocket. Here is a simple demonstration of how advanced Chinese were. Emperors from Ming dynasty sent large fleets to discover farther lands. Some of them reached Africa. This happened decades before Western exploration age. Roman. Intensive and well-managed agriculture was developed by Roman. A great contribution was made by existing Iron Age technologies in these developments. They implemented laws for ownership of individuals. Some of their major technological advancements are as following. Advanced stone masonry technology. Road building technology, in 19th century though. Military engineering. Civil engineering. Spinning machine. Weaving machine. Gallic reaper. All these technologies heavily supported Roman economy. Following architectures were built across Roman Empire by various engineers, first time ever in the world. Monumental arches, aqueducts, public baths, amphitheatres, true arch bridges, harbours, reservoirs and dams, vaults and domes. Concrete, glass blowing and book codex are some most important contribution of Roman in the field of technologies and innovations. The concrete developed by Romans was durable since it was located on volcanic peninsula. These areas are full of sand and suitable for crystalline grains. There are several Roman buildings that lasted from 2000 years to present date, providing proof to their concrete quality. Inca and Mayan. Inca and Mayans are famous for their ancient engineering, which matched standards of today's advanced engineering. They were so good with weighing and stoneworks that not even a blade could fit in the cracks of their stone walls till the day. Agricultural activities were made efficient by implementing proper irrigation canals and drainage systems in their villages. Inca people are said to be the inventors of hydroponics. However, it is quite uncertain since their agricultural technology was still soil-based. There was no metallurgy or wheel technology known to Mayan civilizations. However, complex writing and astrological systems were developed by them. They have given the world heritage of sculptural stone and flint works. Agricultural and construction technologies were greatly advanced in both the civilizations. In ancient period, most of the buildings and structures developed by Mayan people were built by women, since they believed that God has appointed women for creation of new things. Aztec rules contributed a lot in communication, took place with conquered cities. Similar to Inca and Mayan civilizations, roads were designed for travelling on foot in Mesoamerica, since there were neither transports nor wheeled vehicles. Greek. Myriad inventions and improvements in existing technology was kind of favourite activity of Greek and Hellenistic engineers. Technological enhancements were at their peak during the Hellenistic period. Following were some great men from this region and era: Archimedes, Philo of Byzantium, Heron, Ctesibius, Archytas. Chapter 3. Medieval to Early Modern Technology. Islamic World. In technological terms, medieval Islamic empires were much similar to earlier empires. Muslim caliphates managed to unite trade large areas that were never involved in large-scale trades before. The conquered areas were required to pay a little bit lower taxes compared to their earlier independence. People were so in favour of technological developments that ideas were spread more easily around the empire compared to goods. They made peace more frequent and long-lasting than it used to be. Due to increasing facilities and conditions, many technological developments, including agriculture, witnessed quite a boost. During this period, many scientific concepts were adapted and developed from Greek, Roman and Persian empires in their improved forms. Medieval Europe. European technology was in the golden phase of development in medieval ages. This phase is also known as tradition of innovation and inventions. It is certain that medieval technology is quite a bit slower and backtracked compared to development of Western technologies. There have been multiple authors criticizing and denouncing the Church as antagonistic for scientific progress. Who can forget myth of flat Earth? However, it is certain that Europe contributed significantly in development of global technology. Some of their major contributions are mechanical clocks, spectacles and vertical windmills. There were also some seemingly inconspicuous items developed in medieval Europe, such as watermark and functional button. They also contributed a significant amount of effort in triggering the age of exploration with some useful navigation innovations by introducing followings: Pintle and gudgeon rudders, lateen sails, dry compass, horseshoe, astrolabe. Talking about military technology development, there were some magnificent results too. Medieval Europeans developed plate armour, steel crossbows, counterweight trebuchets and cannons. Most of the agricultural advances were achieved in early Middle Ages. Inventions such as rib, vault, and pointed arch triggered Gothic-style agriculture. Age of castles was triggered as ubiquitous medieval fortifications were established. Papermaking technology was developed in 2nd century. It was carried into Middle East as a group of Chinese papermakers were captured in 8th century. As Umayyad conquered Hispania, technology of papermaking spread was all over in European empires. First European paper mill was located in Sicily, which was built in 12th century. In Europe, linen and cotton rags were used as a source to acquire the fibre pulp required to make paper. Lynn White believes that spinning wheel is an important technology for rise of printing technology. Wheel made it easy to supply rags where required, ultimately reducing producing costs. It was a major contributing factor in rise of printing press. Renaissance technology. Following are some significant technological advancements of this era. Linear perceptivity, double shell domes, bastion fortresses. Dome of Florence Cathedral is a great example of such technology. D'Arcola and Leonardo da Vinci have left behind a number of books related to Renaissance technological advancements. They are considered a great resource for acquiring broad details about mechanical technology available and used in that period. Architects and engineers were heavily inspired with structures such as of ancient dome. Dome of Florence Cathedral was developed by such an inspired architect-engineer, Brunelleschi. He was some of the very first persons who were issued with patents over their assets. He patented his ingenious crane that he developed and used to raise large masonry stones to the top of the structures. Military technology too developed during this era. Their military was so advanced compared to others that use of powerful artillery and crossbows was common to them. This advancement was certain since most of the Italian states have been constantly involved in conflicts with each other. There were families like Medici with strong knowledge of art and sciences as well. Mutual advancements were followed in science and technology known as scientific revolution, still a great contribution of Renaissance science in global technological development. Olive screw press was developed in AD 1441. Pressing mechanism of this press was also adopted for investing cast metal type printing press, which was a movable machine. Number of books and number of publications were greatly increased thanks to this invention, ultimately giving a boost to spread of the technological and other news worldwide. Chapter 4. Age of Exploration and Industrial Revolution. Age of exploration was triggered as Europeans began to colonize American regions, exploring more and more land into the west thanks to improved sailing ship technologies. New Atlantis by Francis Bacon served as epitomizer of a process or era. Before the age of exploration, land routes were more famous compared with much faster water routes. In this period, world was constantly being explored more and more by multiple people like Cabral, Vasco da Gama, Magellan, Christopher Columbus, and many more like them. These people were involved in this activity since they required establishing new trade routes for their goods. On the other hand, they were also discovering water routes to decrease travel time, establishing connections with Africa, India and China. As results, water routes soon became more popular over land routes since they conceded less time and resources. New maps, charts, etc. accessories were produced in order to encourage future mariners to explore the world till the end is found, since there were many problems including longitude and there were no accurate chronometers. These limitations made navigation comparatively difficult than it became after the age of exploration. Ancient Greeks developed the concept of civil codes, which was lost into the pages of history. European powers re-established or rediscovered these systems, as it was essential, since their colonies were expanding constantly with new findings. Industrial Revolution. Following are the major developments that took place in the era of Industrial Revolution. textile manufacturing, mining, metallurgy, transport. All these areas witnessed massive-scale technological advancements and developments thanks to a single invention of steam engine. This revolution was triggered thanks to the optimization of coal, which was capable of producing significant amount of energy at a comparatively cheap cost. In Britain, it was produced in the largest amount ever during the era of Industrial Revolution. Techniques like blast furnace and cast iron produced resources in massive amounts using coke, a form of coal, as a fuel. Major structures could be created thanks to this technique. The Iron Bridge is a great example of results achieved from this technique. Cheap coal allowed the industry to escape from the restriction of water resources used as primary fuel for mills before this era. Despite of coal being the major resource, industry did not neglect the power and usefulness of water energy. Even during Industrial Revolution, it remained as a major secondary power source used in smaller units, where using coal was not possible or comparatively expensive. Here is a demonstration. Water was essential for running steam engines. Steam engines were essential for draining mines, allowing access to more and more coal reserves. As soon as this technique was developed, most of the major mines implemented it for increasing coal output, since it was being used as primary fuel in most of the industry. Since water energy was essential for increasing coal produce, it managed to remain a valuable resource during Industrial Revolution. With time, steam engine technology was tweaked and evolved, producing high-pressure steam engines as an output. These high-pressure engines were used in developing locomotives, ultimately triggering revolution in transport revolution. Chapter 5. Technology in 19th century. Some historians refer to 19th century as Second Industrial Revolution, since this period witnessed some fascinating developments in the field of construction, manufacturing and communication technologies as well. Most of these technologies were originated in Europe. Steam engine was developed in early 18th century. However, it was never involved in transportation. In 19th century, it was practically applied in steamboat and railway transportation. First purpose railway line was built in 1830 by Liverpool and Manchester Railway. First working locomotives were rocket locomotive and Robert locomotive. Telegraphy was also developed in 19th century, making its practical application possible for running railways more safely. These were the technologies that existed before 19th century. However, in 19th century, they were developed to make their practical use efficient and widespread. There were also some technologies that were developed or discovered for the first time in the period of 19th century. Incandescent light bulb could be most famous example of inventions in 19th century. This invention was important for manufacturing industries, since these bulbs allowed various factories to run second or even third shift regardless to their geographical location. The production rate of factories using this technology was tripled as a result. Pulley blocks were developed at Portsmouth block mills by various ship manufacturers. All these inventions triggered the age of mass productions, since each and every field received quite a boost in their production rate. In the first half of the century, various manufacturing tools were developed by engineers. These tools made it efficient to craft or manufacture various machinery parts. Richard Roberts and Joseph Whitworth were of those engineers who first developed and used these kinds of tools. 19th century was also the period in which manufacturing and development of interchangeable parts began. Nowadays, it is known as the standard American system of manufacturing. It was triggered with its implementation by U.S. federal arsenals in their firearms manufacturing system. It took place early in the first half of 19th century. By the end of the century, it had become widely used manufacturing system in entire United States. In the middle of the 19th century, there were two major enhancements or improvements that took place in manufacturing activities in textile field. First one is that production of shoe was mechanized in that period. Second one, and the bigger one, is that sewing machine were introduced in middle period of 19th century. In the period of mid to late 19th century, these sewing machines were produced at a massive scale. Along with the sewing machines, a number of agricultural machinery was too developed at high production rate in that very same period of time. In early 1880s, this attraction turned towards bicycles. In this entire decade of 1880s, production of bicycles was at its peak with sufficient demand as well that was even encouraging manufacturers. By this time, most of the factories around United States had already adopted steam-powered mechanism and functionalities. However, it is noticeable that England has implemented such water-powered factory system much before United States did. However, they still failed to beat US in terms of developments, despite of this advantage. Ironclad techniques were implemented in steam power-based ships soon. These ships played an important role in opening trade routes with Japan and China. This was the first time Western and Eastern worlds connected directly without any intermediate. Ending period of this 19th century is considered the Second Industrial Revolution thanks to major rapid development in various fields of production. During that period, following fields were developed rapidly, also connecting them with technological research with well-developed structure. Chemical, electrical, petroleum, steel. It is quite uncertain how long this period lasted. However, most of the historians refer to Second Industrial Revolution for last third portion of the 19th century to the beginning of World War I. Certain are that the development boost in field of various technologies was even greater and impactful compared to First Industrial Revolution. Chapter 6. Technology in 20th century. Rapid developments were made in technology in 20th century. There were a number of achievements acquired both in science and technology. Scientific methods were taught and implemented on a broad scale during this century. Moreover, scientific researches were increased thanks to the encouragement and contribution which eventually led to significant achievements. Impact of those achievements can be still in modern science and technology. Technical understanding was spread worldwide on a massive scale thanks to significant improvements and advancements achieved in communication and transportation technologies. Many high-tech technologies, including automobile, became efficiently accessible for a mass level of global consumers thanks to the large-scale production rate going up day to day. Significant development and research was conducted for military, resulting as electronic computing and jet engines. Radios and telephony technology was improved at the point it became available globally for most of the populations of worldwide users. However, it was still not possible to provide near universal access. That too eventually became possible as mobile phones were developed and became affordable. In the beginning era of mobile phones, they were quite expensive and not accessible for everyone residing in the developing world. However, by the end of 2000s and early 2010s, mobile phones were developed enough to be cheap for everyone to use. Talking about Asian countries like India, you can get a basic functional mobile phone as cheap as $25 or even less. However, you will have to spend much more for using modern technologies such as camera, GPS, etc. Developments were followed in energy and engine technology as well. While discovering improvements in these fields, nuclear power was eventually developed in Manhattan Project, ultimately triggering atomic age. With a great energy source found, rocket technology began to develop and establish new discoveries rapidly. As a result, Sputnik was launched in 1950s, triggering the first space age. This era lasted till 1980s until more advanced results were achieved in this technological field. In 20th century, like any other technology, electrification was at its peak. When electricity was firstly developed for household applications, it was available in limited cities, only such as major cities like New York, London, Paris, Tyne, etc. Moreover, they were accessible and affordable for wealthy people only. However, in 1990s, World Wide Web was invented, which managed to provide electricity to almost 62% households around the globe. It is noticeable that 1/3 part of this population was residing in rural, still developing areas or regions around the world. Birth control was a widespread and major global issue in 20th century. In late 1970s, electron microscopes were the most powerful ones in their category. They contributed a lot in order to increase understanding and knowledge in the field of genetic engineering. In 1978, a major success in genetic engineering was achieved as Louis Brown, the first test tube baby, was born with any dependencies. Soon, in 1985, first gestational surrogacy pregnancy was successfully conducted. Eventually, after 6 years, in 1991, first pregnancy by ICSI was achieved successfully. In ICSI, a single sperm is implemented in an egg by artificial process, not natural one. In 1989, experiments began with pre-implementation genetic diagnosis, resulting successful births within a single year in July 1990, clearly indicating how rapid the development was in that period of time. These procedures are constantly being developed and reached to common populations. These concepts have changed the meaning of being a parent. In order to keep transatlantic research programs running, major data analysis resources were essential. Human Genome Project and the Large Electron Positron Collider are great examples of such large-scale projects. These projects required advanced distributed communications, resulting researchers to adopt Internet protocols at a massive scale. Tim Berners-Lee developed the practical concept of World Wide Web in order to satisfy the requirements of major data analysis resources. Neither did these requirements exist, nor did we have Internet today. In developing world, vaccination was spread on a wide scale on a global level 1980s onwards. There were many reasons behind this, most important being a number of successful humanitarian initiatives, reduced childhood mortality in poor countries with limited medical resources, etc. Following is a list indicating top 20 technological developments of 20th century. This list has been prepared by National Academy of Engineering, United States. Ranking in this list have been defined according to debate between various experts from related technological fields. First, electrification. Second, automobile. Third, airplane. Fourth, water supply and distribution. Fifth, electronics. Sixth, radio and television. Seventh, mechanized agriculture. Eighth, computers. Ninth, telephone. 10th, air conditioning and refrigeration. 11th, highways. 12th, spacecraft. 13th, internet. 14th, imaging technology. 15th, household appliances. 16th, health technology. 17th, petroleum and petrochemical technologies. 18th, laser and fiber optics. 19th, nuclear technology. 20th, materials sciences. Remember that these ranks are according to their importance and not according to the timeline in which they were invented. Chapter 7. Technology in 21st Century. We are currently living in quite early phase of 21st century. However, development and technological advancements achieved in this short time span can easily beat researches done in entire 19th century. Following is list giving quick glance at technological developments and fields achieved in 21st century until now. Quantum computers have been introduced. Research are going on in gene therapy that was introduced back into 1990 AD. 3D printing has touched new heights like never before. Original concept was introduced in 1981 AD. Nanotechnology, bioengineering and biotechnology, nuclear technology. Many advanced materials are introduced or discovered, like graphene. The scramjets and drones are being used by military since they can be equipped with high-energy laser and railguns. Conduct of superconductivity has been introduced. The memristor, development of green technology and alternative fuels such as fuel cells, self-driving electric cars, plug-in hybrid cars, etc. Augmented reality devices and wearable electronics have been developed. You can forget the artificial intelligence in the list. Powerful LEDs, solar cells, IC technology for computers, integrated circuits, wireless power devices, electronic or fuel engines, portable and powerful batteries. All this achieved in time span of barely 1.5 decades. Large Hadron's Collider is considered the greatest, both in technique and size as well, research tool built in 21st century. It is the largest machine ever in entire human history. It is expected that instruments such as large particle accelerators such as LHC and neutrino detectors will help to increase our understanding and knowledge about particle physics. Underground detectors are constantly involved in the activity of sorting dark matter. On the other hand, observatories such as LIGO are working in order to detect and understand about gravitational waves. Like 20th century, genetic engineering achieved some useful results in 21st century too. Importance of epigenetic has greatly increased in the field. Inheritance is a well-developed, known concept nowadays. Astronomy is going through a large-scale revolution with invention of spacecrafts such as Orion and Dragon. These inventions have given us spaceflight technology a new point of view. Space telescopes are greatly developed compared to old traditional telescopes. These telescopes are constantly being developed and improved. In 2000s, International Space Station was successfully completed. It is estimated that NASA and ESA are going to launch a manned mission to Mars in 2030s in collaboration. In 2015, VASIMR Variable Specific Impulse Magnetoplasma rocket was tested. It is an electromagnetic thruster in order to be used with spacecraft propulsion. First manned commercial spaceflight took place in 2004 when world saw Mike Melville crossing the boundary of space on the 21st June of 2004.